So we're going to use our trig ratios and maybe other formulas to figure out all the missing sides and angles of this right triangle. Now this one and the next one, I'm specifically using, instead of A and B, I'm using X and Y. This is especially for those in CNC. If you haven't gotten to this yet, you will, that usually our horizontal is X and our vertical is Y. That's what we do to be consistent. And then if there's a third dimension, it would be Z. So in this one, I'm given angle 53. So if I want to start off using that, I can. So I would definitely then need to use 24. So let me do my labeling. Hypotenuse, opposite, adjacent. So I definitely need to use my adjacent. Now the difference here from what we've done before is everything's unknown. So I could pick, do I want to find my opposite side, my hypotenuse, my angle? And, actually angle A would be a little easier to find right away. Let's do that because those two angles, the 53 and A, have to add up to 90. So we could do 90 minus 53 is 37. Okay, but let's keep the focus on that 53 since I already did my labeling off of that. Okay, so just be careful. If you find the other angle, I would stick with whatever you're given first as your angle that you're focusing on. So let's do opposite first. It doesn't matter if you want to find hypotenuse first, either way. So if I focus on opposite and I have to use adjacent, then I'm going to use tangent. Tan 53 is opposite over adjacent, so y over 24. Y over 24. So this is situation 1, unknown on top. So I'm going to take the side I know times my trig part. 24 times tan 43 is 31.85. Tenth of a millimeter though, so actually it's 849, so it's a little closer to 8. 31.8 millimeters. Okay, so now I've got A. That's done. I have my side Y. That's done. Now I just have to find side C. Now I could use one of my trig functions. Maybe do adjacent over hypotenuse, use cosine. But if I know two of the sides now, and I want the third side, I could go back to the Pythagorean theorem, which this would be an add situation. A squared plus B squared, or X squared plus Y squared. 24 squared plus 31.8 squared. And then the square root of that. So I'm going to do that all in one step. Square root 24 squared plus 31.8 squared to the nearest tenth of a millimeter would be 39.8. And if I do kind of a look, see if this all seems about right. 24 is across from 37 degrees. That's the smallest side. The hypotenuse is the biggest side. So it all seems reasonable. Okay, now the next one. Okay, this one now I'm missing two angles. Both angles I don't know. And then I'm missing the X. And we'll deal with the X first. We'll do the Pythagorean theorem again. Okay, so this would be, if you want to go back to the Pythagorean theorem labeling, this would be across from angle B would be side B. So this is like I'm solving for B or X. So this is one where I would subtract the squareds and do the square root because I know the longest. I know the 7 1/4, that's my C, my hypotenuse. So that goes first, 7.25 squared minus 2.75 squared. So we take our longest side squared minus one of the legs that I know. Okay, so all of that square root 7.25 squared minus 2.75 squared. I'm getting 6.708. Okay, 1/16 of an inch. This one's a little close. I think I'm kind of right between, a little closer to 11/16. So it's 11.3, so 6 and 11/16. Yeah, 6.875. That would be closer to 0.708 than 0.75 up to 3/4. Okay, so there's my x. Now I have to find my angles. So I have to make a decision here. Do I want to find A or do I want to find B? And I haven't done any labeling yet, so I guess just to go with alphabetical order, let's find A first. And just looking at it, definitely should be smaller. It should be a smaller angle. Definitely less than 45. So opposite, hypotenuse, adjacent. Now, I could technically do anything here. I could do sine because I know opposite hypotenuse. I could do cosine because now I know adjacent and hypotenuse, or tangent because I know all three sides. But usually best to stick with what we were given originally. So let's do opposite and hypotenuse. Opposite and hypotenuse is sine. So sine, I don't know angle A, is opposite 2.75 over hypotenuse, 7.25. So this is where I do second sine to get that inverse. 2.75 divided by 7.25. Second sine, 2.75 divided by 7.25. And I'm going to the nearest tenth of a degree, so 22.3. And I'm going to make sure to put A there so I don't get them mixed up. Okay, we said it should be pretty small, so that's good. It is. Now to get angle B, I could do 90 minus that. 67.7 degrees.